Hi, I am Noor Fatma Mansoor, and today in this lesson 2 part 1 we're gonna talk about topic modeling with SVD and matrix decomposition. So let's get started with this new video. So this is the first part of our lesson 2 of NLP, natural language processing. So these are the highlights of today's video, and these are the objectives, like the main topics we will be covering, the main topics like on which the video is based. So the first one is matrix decomposition and the second one is topic modeling with SVD. What are the outlines of today's video? Let's see. Okay, so first we will be covering what is matrix decomposition, then we will see motivation in matrix decomposition, stop word stemming and lemmatization, then we will be going through what is sentence piece and data processing. So the idea is that you have a collection of documents or collection of text, and so here is an example showing some of the plays of Shakespeare. And you represent them here as bag of words, and just kind of taking the word count from different words. So Anthony here appears a lot in Anthony and Cleopatra, but not in the Tempest or Hamlet. Yeah, so this is the word Anthony is not in the Tempest or the Hamlet plays of Shakespeare. So this is a way how you can represent these plays of Shakespeare as a matrix. This is actually called a term document matrix. Okay, so now let me explain that what actually is matrix decomposition. So matrix decomposition is breaking down a matrix into simpler components to simplify calculations or extract meaningful information. And there's also something called latent semantic analysis, LSA, and so what is motivation in matrix decomposition? So the motivation in matrix decomposition is to find a simplified representation of a matrix that captures like the essential patterns or structures present in the data, allowing us to better understand and analyze it. So let's go for the code. So yeah, here's the code. So this is the code. So here we will be using scikit. And 20 newsgroup dataset, which is available in scikit-learn data analysis by datasets by default. So newsgroups were like discussion groups on Usenet that were popular in 80s and 90s. These were kind of bulletin boards from the earlier days of the web. This dataset includes 18,000 newsgroup posts with 20 topics. So here are some tutorials. I have mentioned them. So there are some tutorials which will really help you for learning about scikit and NLP. So you can take this one, which I really like. Like there's a text analysis with topic models for humanities, and let's open it. Humanities. Okay, so I think that's a GitHub link, so let's come here. So this tutorial was actually on humanities and social sciences using a British literature dataset, which I will show tiny bit of it later. So now look at our data. Okay, so we're gonna pick 4 categories. So I picked out atheism, religion, computer graphics, and space. So I just picked out 3 messages. Let me show you. So these are the 3 messages. So the first one is, I have noticed that if you only save a model with with all of your mapping planes positioned carefully to a 3D file that when you reload it after restarting 3D. So what do you think this first message is about? Yeah, this is about computer graphics. So the next one is, this seems to be a borrowing evidence to the contrary that Koresh was simply another deranged fanatic. What topic do you think it is? So I think that I will let you think, then I will tell you. So this is actually about religion. This next topic, this was about religion, and now come to the last one. Here is the last one. Okay. Okay, so obscuration and just picked out. I cannot find the last one, so let's jump to the. So actually the last one was about space. Yeah, here mentioned, but I don't know where did it go. So here I checked, so they were actually, so we checked here, so they were actually computer graphics, as you can see, religion and space. So the next thing is that what is a target attribute? A target attribute is like that refers to the specific feature or characteristic we want to extract or predict from the given data matrix. So to choose how many topics here. So to choose how many topics you want to create, and so that's something. Here I have set like 6 to see. Here 6 to see what I get, but but you could try running this with different numbers of topics, because you think about, like, if you are looking for clusters in a group, you don't know how many either truly are, and that they are often, there's not true there, like node granted. Here this is an unsupervised data set data. So yeah, this was about that. And now I want to talk about I want to little aside about stop words, stemming and lemmatization, because this is something you hear a lot talking about NLP, and you need to do this as a part of your data processing. So from Christopher Manning, intro to information retrieval. So stop words are actually like some extremely common words which would appear to be of little value in helping select documents, matching a user need, are excluded from the vocabulary entirely. So these words are called stop words. And here's the information retrieval book does not that. So this note is about like the general trend in information retrieval systems over time has been standard use of quite large stop lists, like 200 to 300 terms, to a very small stop list like 7 to 12 stop lists. So this is not a stop list whatsoever. Web search engines generally do not use stop lists, so they are falling out of favor, but we're gonna use one here since this is a pretty simple model. So from scikit-learn feature extraction, so we can extract the feature extraction from scikit-learn. So you can import stop words. I have just listed the first 20, and so this is a longer list, but these are the words that were thought not to have much meaning. So let me show you the clear words. So yeah, so these are the stop words in scikit-learn. These words will be more useful if you're doing language modeling. So okay, so the next step is stemming and lemmatization. Are the below words the same? Here, organize, organizes, and organizing, democracy, democratic, and democratization. So stemming and lemmatization both generate the root of the words. So root of the words. Lemmatization uses the rules about a language. Uses a rules about a language rules about a language, like we can say the resulting tokens are actual words. So quote stemming is the poor man's lemmatization. So that's where you chop the end of the word. It's crude, heuristic. It is like faster, and that's the benefit of the stemming. And there are also some of the words which was I was so curious about. I was just curious about that I would do in it, and there's no canonical, like there are stem words. So let me show you. So this is, we are importing stem for the from the NLTK library. So it is not like canonical, like it is what the stems have to be here or a limit of doing it. But it's gonna depend on the implementation. I looked at feet, foots, and footing. So here and here for the lemmatization, the first three went to the foot and the last went to the footing for the stemming. Well, this is something you kind of think about if you are doing a simple application, like do you want to group together these words of related words, this kind of words of related words. So now I want to show you guys to try stemming. I want you guys to try stemming on your own. Here I got an exercise for you actually. So I want you guys to try stemming and lemmatization with these words. Fly, flies, flying, organize, organizes, organizing, universe, and university. So you can try this, and then okay. I also wanted to note that stemming and lemmatization are dependent languages with more complex morphologies, which can show bigger benefits. For example, let me open this. For example, I have read that the Sanskrit has a very large number of verb forms. So you can get down here. Here you can see. So you can get down here to like their singular, plural, and you can see dual here. So and for the personal endings we can see, and here's a lot to do with Sanskrit. I don't know about it. Sanskrit, sorry. I don't know about it much, so let's get back. Okay. So there can be like hundreds of ways to modify a word. Yes, you will be working with the different languages. So stemming and lemmatization are implementation dependent. So I tried to run with this code with spaCy, and we won't be using it in course, but you can explore it. And so here's the code. So here I just used feet, foot, and feet, footing again. So these are the stop words from NLTK now, spaCy, sorry, now. So, and I used to illustrate how stop words vary from library to library. So you can clearly see that spaCy stop words are different from the scikit-learn stop words. So another exercise for you is to try what stop words appear in spaCy but not in sklearn. You can take some minutes to compute. Oh, let me just hide it. Okay, I'm not debugging it. Okay, so this is a solution for the exercise 1, and I got another exercise. So the next exercise is the reverse of it. So like what stop words appear in sklearn but not in spaCy. You can try this. So this is the solution for it. So when to use these things, as I mentioned earlier, in more complex and in particular in deep learning, this could hurt your performance really bad because there are a lot of ways of throwing information. So although it can be useful when you have a simpler model and are not able to capture that complexity better, and then I found another approach which is sentence piece. You can also check it out because I haven't had a chance to try. So coming back to the problem at hand about topic modeling. So this spreadsheet thing we will look after. So these are the postings of here we will be using the postings of the four categories I picked out: religion, atheism, um, computer graphics, and space. So today we will be using scikit-learn's count vectorizer. So here we made the vectorizer out of the scikit-learn library. So here's the shape of our data. So we can see it's 2034. So 2034 by 26,576. So the 2000 is a different posting. So those like are separate guests, like the modern equivalent. You could think of like Reddit or any other discussion sites. And then we've got and then we have 26,000 tokens on words using in those Reddit's posts or any other sites post. So then we have okay, so there's a list of words 7,000 and 7,020 alphabetical order. So we kind of have all these words starting with CO. You can see here all of these words are starting with CO. So before we dive into SVD, I want you guys to know about like how it would be in a spreadsheet. So in a spreadsheet you can see here are the like plays, and here are the words, and these are the plays. So here we can see Austin Sense appears 0 times in Adams. In Allworthy is also 0 times. In Brendan I don't know the full name, so it's 0.14, or how many times it appeared in Brendan. In Catherine it's also like 0, and it will tell the frequency, like how many times it appeared. So it would look like this in spreadsheets. So I wanted to show you guys because it would be you will have literal idea like how we are gonna use the SVD in our next part of this lesson. So this is all about today. I'll meet you guys in the next part. Till then, take care. Bye bye.